In this short video, we're going to be learning how to solve indefinite integrals. In the last video, we taught you how to solve definite integrals. And we can see that they are definite because they share a notation of a, b, fx, dx. Indefinite integrals look like this, fx, dx. Now we can notice that one thing is missing from the indefinite integral that the definite integral has. It's these upper and lower bounds. But without these lower and upper bounds, we're not going to get an answer. Because remember, first we take the antiderivative of the function, and then we take the upper limit, the upper boundary, and subtract it from the lower boundary, substitute it into the antiderivative. But with this, we don't have an upper bound or a bottom bound. So how do we solve one of these? Well, it's easy. The indefinite integral is basically just a fancy way of saying we're just taking the antiderivative. Because remember, the antiderivative doesn't have something that we're going to know that's an antiderivative. For example, for the derivative, we know that we're taking a derivative because it looks like an fx, a dy dx, or dx and or your function. But for an antiderivative, we don't have one of these symbols to say that we're taking the antiderivative. So instead, we use the indefinite integral to tell our audience that we're actually taking the antiderivative. And so, if we have a function like 3x squared, 3x cubed plus 2x squared plus x plus 1, well, then if we put that in an indefinite integral, then we just take the antiderivative. So that will give us 2 over 3 plus x to the power of 2, 1 over 2 plus x. And since we're taking the indefinite integral, we actually have to take a c. Because basically remember that this is just an antiderivative. And when we have an antiderivative, we have a constant that is undefined. Alright, but some people from the last video asked that, how come there's no c when we take the definite integral? Okay, I'll give you an example right there. How about we'll use the same function? So, 1 and actually 0 and 1, because those are easy numbers. 3x cubed plus 2x squared plus x plus 1 dx. Alright, let's refresh. So we first take the antiderivative, which I'm going to do right now. x3 plus 1 is 4. 3 over 4 plus x to the power of 3, 2 over 3 plus x to the power of 2, 1 over 2 plus x. But since it's an indefinite integral, we don't have to put a c. But just in this case, I am going to put a c. Alright, and then we do our next step. Put a line and our upper and lower bounds. And then we substitute these bounds for all of these x's, which is going to leave us with 3 over 4 times, well, which is going to leave us with 1 times that, which is 3 over 4 plus 2 over 3 plus 1 over 2. And that would be our answer. And see, even though we had our c over here, it had no effect on our answer because there's no x correlated to it. This is not a coefficient of x. So even if it was there, then it wouldn't have any effect on it because all of these have x's, but this does not have an x. So we can put it there if we wanted to, but since a lot of people don't, many people just leave it out of the indefinite integral. So today we learned why that we don't put a c in an indefinite integral, but we do put a c in the definite integral. How this makes how an indefinite integral is a fancy way of saying an antiderivative, and an indefinite integral is similar to it, except it has an upper and lower bounds. Now that we've learned all of this, let's take some of these skills and things we just learned, and let's put them to use and practice some of them. Let's go. Okay, so if we have a function, for example, fx of x to the power of 100, then give us the indefinite integral from the area underneath this curve from 0 to 10, and also the indefinite integral of this. So the definite integral will be from 0 to 10 of x to 100 dx, and the indefinite integral will give us x to the power of 100 dx. Now just a refresher, each part of this means something different. This is our actual function, this is our dx for that one little slice. And when we take an integral, some people ask, well, where does the dx go? Well, it's kind of like this. Remember, if we have our steep curve and we have our little slice, right? So the width of the slice is dx, and the height of that slice will be our function, which is fx. Well, guess what happens to these two? Well, they have to multiply to each other. And multiplying each other not only destroys the dx, but also, well, I shouldn't say destroy, but morphs these two. They kind of go into each other, aided by this sign, and turn into the antiderivative. So the function joins with this to get our area with the slice, which means that this and this becomes a single function, and then this basically just sums it up. And that's why the dx kind of disappears. When we have our dx and our height, which is our width and height, we get the area of a rectangle. And since the rectangle is so thin, the little curvature at the top doesn't matter anymore. And with this sign means that we're adding all of the rectangle area from 0 to 10, from this to here, and we get the total area. Here we can see that it's just trying to sum up everything. But we have no bounds. So in theory, it would be infinity. But we can't call it infinity or else it would just be useless. So basically, we just derive a formula from it that that's basically just the antiderivative. Alright, since that was just a refresher, let's go on to the actual question. So what's the antiderivative of this into the function? 100 plus 1 is 101. And we have to take 1 over 101. And then we have our line, 10, and 0. And just by looking at this, we can tell that it's going to be quite massive, which would basically give us 101 over 101 times 10 to the power of 101. And since this number is going to be super huge, we don't have to calculate it, but this can just be calculated by somebody else, or the answer can be left like that. Alright, and since we already know that this is just the antiderivative, and we kind of already solved for the antiderivative there, we can just put it like this. But remember, since this is an antiderivative, since here it's an indefinite integral, we don't have to put a c. But since this is an indefinite integral, since this is definite and this is indefinite, then this we have to put a c. Remember, an indefinite integral means that we have no bounds. A definite integral means that it has definite bounds. So a definite integral will give you an answer, an integer, unless one of its bounds is an x, and the indefinite integral has no answer and instead gives you a formula in return. Alright, now let's go to another special example. Let's say we have an integral, but instead of numbers, we have an x as a bound. And then we have, let's just have an easy function this time, 3x squared plus x dx. Alright, what are we going to do with this bound? Well, it's kind of just the same process. So, antiderivative, x to the power of 3. 3 over 3 is just 1, so you don't have to add that. Plus x squared 1 over 2. And then we add our line, x and 0. And then just like this, we can just treat this x like a normal number. So we can just substitute all x's for x, and they'll just give us square. Whoops, that might look like a 3, so there we go. But let's say it was 2x. Then what would he do? Then we just substitute all x's with 2x. So 2x, 3, 1 over 2, 2x to the power of 2. And since the bottom base is 0, we can just omit it, because 0 to the power of 3 is 0, plus 0 to the power of 2 times 1 over 2 is still 0. So even if it just was subtracted, subtract by 0, it's just still going to be this equation. But what if it wasn't 0? What if it was, say, 2? Well, then we'd have to substitute this into there. So we'd bracket this off, subtracted by 2 to the power of 3, which would be 8. 8 plus 1 over 2 times 2 to the power of 4, which is 2. So it would be, so this would be 2x to the power of 3 plus 1 over 2, 2x squared minus 10. And we can simplify this down to 8x cubed plus 1 over 2 times 4x, no more back bracket, 4x squared, and those 1 over 2 and 4 would turn into a 2, minus 10. And that would give us our final answer. And just like you see before, when a definite integral has an x as a bound, then it doesn't return an answer to us. It returns a function. Because if you imagine in your head, this x can be anywhere, right? So if we have our function, our bounds can slide from one position to another, giving us different areas. And depending on the position of the slider, we can give us our area under the curve. So this has been a practice and a tutorial on the indefinite integral.